When one is looking for something to buy, one searches the net for possible sellers. When he finds one, purchase is done. During this process, the seller gives out information or specification on the products being sold. When the buyer sees this and buys it, he then gives his personal information and payment options. Data collected are exchanged between the seller and the buyer. The following involved computers, mobile phones, airline reservation system, and PlayStation 2. Examples of telecommunication technology are airline reservation system and a mobile phone. And the answer is the Salamis tablet. The Salamis tablet was an early counting device dating from around 300 BC that was discovered on the island of Salamis in 1846. A precursor to the abacus, it is thought that it represents a Babylonian means of performing mathematical calculations common in the ancient world. Pebbles were placed at various locations and could be moved as calculations were performed. The marble tablet itself has dimensions of approximately 150 by 75 by 4.5 centimeters. Zero was invented by the Hindus in 650 AD. The Hindu-Arabic numerals and the positional number system were introduced around 500 AD, and in 825 AD, it was introduced by a Persian scientist in his book on arithmetic. This book synthesized Greek and Hindu knowledge and also contained his own fundamental contribution to mathematics and science, including an explanation of the use of zero. And the answer is false. Napier's bones is an abacus created by John Napier for calculation of products and quotients of numbers that was based on Arab mathematics and lattice multiplication. Using the multiplication tables embedded in the rods, multiplication can be reduced to addition operations and divisions to subtractions. More advanced use of the rods can even extract square roots. And the answer is the calculating clock. Wilhelm Schickard was a German polymath who designed a calculating machine in 1623. 20 years before the Pascaline of Blaise Pascal. Unfortunately, a fire destroyed the machine as it was being built in 1624, and Schickard decided to abandon his project. Unknown to the world for more than 3 centuries, it was rediscovered in 1957 and therefore had no impact on the development of mechanical calculators. And the answer is true. Babbage's first attempt at a mechanical computing device, the difference engine, was a special-purpose calculator designed to tabulate logarithms and trigonometric functions. Construction of this machine was never completed. During this project, he realized that a much more general design, the analytical engine, was possible. The input, programs and data, was to be provided to the machine via punch cards, a method being used at the time to direct mechanical looms such as the jacquard loom. For output, the machine would have a printer, a curved platter, and a bell. The machine would also be able to punch numbers onto cards to be read in later. It employed ordinary base 10 fixed point arithmetic. There was to be a store, that is a memory, capable of holding 1,000 numbers of 50 decimal digits each. An arithmetical unit would be able to perform all 4 arithmetic operations plus comparison optionally square roots. Initially, it was conceived as a difference engine curved back upon itself in a generally circular layout with a long store exiting off to one side. Thomas Edison invented the light bulb. The incandescent light bulb, incandescent lamp, or incandescent light globe makes light by heating a metal filament wire to a high temperature until it glows. The hot filament is protected from air by a glass bulb that is filled with inert gas or evacuated. In a halogen lamp, a chemical process returns metal to the filament, extending its life. The light bulb is supplied with electrical current by feed-through terminals or wires embedded in the glass. In 1904, John Ambrose Fleming invented the two-electrode vacuum tube rectifier, which he called the oscillation valve, for which he received a patent on November 16. It was also called a thermionic valve, vacuum diode, kinetron, thermionic tube, or Fleming bulb. The Supreme Court of the United States later invalidated the patent because of an improper disclaimer and additionally maintained the technology in the patent was known art when filed. This invention is often considered to have been the beginning of electronics, for this was the first vacuum tube. Fleming's diode was used in radio receivers and radars for many decades afterwards until it was superseded by solid-state electronic technology more than 50 years later. The Audion is an electronic amplifying vacuum tube invented by Lee DeForest in 1906. It was the forerunner of the triode, in which the current from the filament to the plate was controlled by a third element, the grid. A small amount of power applied to the grid could control a larger current from the filament to the plate, allowing the Audion both to detect radio signals, that is, make them audible, and to provide amplification. However, the Forest Audion is quite distinct from the true vacuum triode, in that it is not capable of linear amplification. The Atanasov-Berry computer was the first electronic digital computing device, conceived in 1937. The machine was not programmable, being designed only to solve systems of linear equations. It was successfully tested in 1942. However, its intermediate result storage mechanism, a paper card writer or reader, was unreliable, and when inventor John Vincent Atanasov left Iowa State College for World War II assignments, work on the machine was discontinued. The ABC pioneered important elements of modern computing, including binary arithmetic and electronic switching elements, but its special-purpose nature and lack of a changeable, stored program distinguish it from modern computers. The computer was designated as IEEE milestone in 1990.